Hello, welcome to the Wealth Starting Line. Don't forget to like, comment, share, and subscribe.
Have you ever wondered what sparks a world-changing idea? Is it a single flash of genius, or is it a whole lifetime of dedication? Well, in this explainer, we're going to unlock the minds of the 2025 Nobel laureates. We'll see how a really simple question can lead to a breakthrough that ends up impacting every single one of us. So let's dive in.
First up, we'll look for that spark of discovery. Those personal moments where all began. Then, we're going to dive deep into their incredible work across economics, chemistry, medicine, and physics. And finally, we'll connect all the dots and see what their combined vision really tells us about the future.
So, where does a Nobel-winning idea even come from? It's almost never in some high-tech sterile lab. Nope. More often than not, it starts with a simple moment of human curiosity. Just a single question that a person can't let go of.
For chemistry laureate Omar Yaghi, it all started when he was a 10-year-old refugee. He found an unlocked school library and was just captivated by a book filled with drawings of molecules. To him, it was like discovering a secret, beautiful world, and that sparked a passion that lasted his entire life. For physics laureate John Martinez, that spark was a daily ritual at the dinner table. Every night, his parents would ask him one simple thing. Did you ask a question today? That's it. But that one mandate trained his mind to be constantly curious, and it ended up shaping his whole career as a scientist.
And you've got to love this one. For his fellow chemistry laureate Susumu Kitagawa, it all started with childhood disappointment. Rain kept canceling his school events, and he got so fed up that he decided, one day, I'm going to be a scientist so I can control the weather. And that set him on a path to master the very building blocks of nature.
All right, let's turn to our economics laureates. They took on a massive question. How did humanity create all the prosperity we see in the modern world? Their answer points to a process that is, well, it's both incredibly powerful and pretty chaotic. We kind of take constant economic growth for granted, but it is a shockingly new thing. Laureate Joel Mokyr has this amazing analogy. If all of human history were a 12-hour clock, sustained growth only kicked in at 5 minutes to midnight. For all the hours before that, life was basically static. So what on earth changed?
The answer is this idea, first coined by Joseph Schumpeter and later modeled by laureate Philippe Aghion. It's called creative destruction. This is the engine of progress, this messy, powerful force where new ideas and technologies are constantly, relentlessly replacing the old ones.
And this cycle is a constant struggle, right? First, an innovator creates something new, hoping to make a profit. Then, that new, better thing pushes the old one out. But then, and this is key, the old guard fights back. They try to block the next wave of competition. And society's big challenge is to manage that tension to keep the whole engine of growth from stalling.
And this is where things get really tricky. To get people to take huge risks, you have to reward them with profits, what economists call rents. But here's the catch. Yesterday's winners can use those very same profits to shut down tomorrow's competition. So policymakers have to walk this incredibly fine line between encouraging today's ideas and making sure they don't block tomorrow's. Okay, let's shift gears now to chemistry. The laureates here have developed an absolutely revolutionary tool to tackle some of our planet's biggest problems, from climate change to water scarcity.
To really get what they've done, you first have to understand the scale of the problem. That number, 1,100 gigatons, that is the staggering amount of extra CO2 we've pumped into the air. It's what's driving climate change, and it all has to come out.
So what's the solution? Well, it's a technology called Metal Organic Frameworks, or MOFs. The best way to think about it is like molecular architecture. These scientists literally build custom crystal skeletons with these tiny, perfectly designed little rooms inside them that can do amazing things, like trap CO2, pull water right out of desert air, or even store clean fuel.
And this leads to an absolutely stunning statement. Laureate Omar Yaghi claims that from a purely scientific point of view, the challenge of cleaning the air is done. The technology to solve the climate crisis already exists.
Which, of course, begs a huge question. If the science is solved, why isn't this happening everywhere right now? What's the roadblock?
The answer is simple, but challenging. The biggest hurdles aren't in the lab anymore. They're in boardrooms and in government buildings. It's going to take global cooperation and, frankly, the will to invest in the solutions that science has already given us.
Okay, so from saving the planet, let's turn to saving our own bodies.
Our next set of laureates discovered our immune system's internal security guards, and in doing so, they opened the door to treating a huge range of diseases. Think about it. Our immune system is this powerful weapon against invaders, but sometimes it gets confused and it starts attacking our own healthy tissue. That's what causes autoimmune diseases. What these laureates discovered were the body's peacekeepers, a special type of cell called regulatory T cells that know exactly when to tell the immune system, hey, stand down. But getting here took decades. The key gene was actually found way back in the 90s, but the technology to use that knowledge just didn't exist yet. It's a classic story of science having to wait for engineering to catch up. But now, finally, it has.
And the impact of this is just profound. Laureate Fred Ramstel says that for decades, the word cure was basically forbidden in his field. You just didn't talk about it. But this discovery has changed everything. For the first time, scientists see a realistic path forward, not just to treating a disease, but to a potential cure.
All right, buckle up. We are taking a trip into the wonderfully weird world of quantum physics. This year's laureates took a truly bizarre phenomenon and figured out how to scale it up, laying the groundwork for the next generation of computers. To really get their work, you have to appreciate just how different the quantum world is. I mean, in our world, if you throw a ball at a wall, it bounces back, every time. But down at the subatomic level, particles can do the impossible. They can pass straight through a solid barrier. It's called quantum tunneling. And here is their mind-bending breakthrough. Everybody thought tunneling was something only single tiny particles could do. But these laureates proved that an entire electrical circuit, an object made of billions of electrons that you can actually see, could tunnel as one. This was the leap we needed to start building real machines that can harness the power of the quantum world.
You know, the famous physicist Richard Feynman once said, if you think you've understood quantum mechanics, you haven't understood it. But these laureates are actually starting to challenge that idea. By showing quantum effects on a scale we can actually see, their experiments are making these bizarre concepts more tangible. They're moving them from abstract math to something we can finally build with.
So, after journeying through all these incredible discoveries, let's zoom out for a second. What are the common threads that tie all of these brilliant minds and their work together?
Because when you get people like this in a room together, you start to see these amazing patterns, these shared challenges, and you get a collective vision for what the future of knowledge even looks like.
And across all their different fields, three big themes kept popping up. First, they all see AI as a revolutionary tool, but one that absolutely needs human wisdom to guide it. Second, they're worried about funding for basic research, the kind of science that needs the freedom to fail to get to those huge breakthroughs. And finally, they all shared this passionate call to reform education, to stop teaching kids just what to think and start teaching them how to think.
And you know, amidst all the world's challenges, the one overwhelming feeling from these laureates is just this profound sense of optimism. The economist Joel Mokyr puts it perfectly. He completely rejects that pessimistic idea that all the big discoveries are behind us. He believes the exact opposite.
And that's really the ultimate message here. These laureates aren't just celebrating the past. They're so energized by their conversations, they've actually decided to write a book together. It's a pledge. It's a pledge to champion curiosity, to fight back against the idea that our best days are behind us, and to prove that human ingenuity is an infinite resource. The golden age of discovery? It's still ahead of us.
Thanks for watching. Don't forget to like, comment, share, and subscribe. See you next time.